anyways, my goal today, go over the whole test top to bottom. Hopefully we can get through it all. Okay. If you didn't finish your test, I know a couple of you are in this boat here, just mark it as you go along. Okay. I don't care about these marks. I'm not recording them. Okay. Use this so that you can improve yourselves, so that you can get better. So, first question. This question's all about converting moles and grams of aluminum hydroxide. So right off the bat, first skill I need you guys to have is you need to know what aluminum hydroxide is. It is AlOH3. So right off the bat, if you didn't get that right, you're probably screwed for the rest of the question. Okay. Then we got to figure out how to do a molar mass. So aluminum is 2698, oxygen is 16, and hydrogen is 1.01. So I just add those three numbers up. No. What did I do wrong? Yeah, these guys we need 3 of because of this 3 right here. So I believe if you do that correctly, I have it written down, the molar mass is 78.01 grams per mole. So there's the second skill I need you to be fairly comfortable doing. First, make the formula. Second, find a molar mass. Neither of those is even the answer yet, though. Now we've got to convert a mole into a gram. So I'm going to show you 2 ways of writing this. You tell me which one's right. So I could do 286 grams multiplied by 78.01 grams per mole. Or I could do 286 grams multiplied by a mole for every 7801. The bottom one. And I'm hoping that as you get more comfortable with this, you'll recognize that this gram and this gram, they don't cancel. This gram and this gram, they do cancel. So this is not right. This one is right. Are you actually timesing these though? You're dividing. Like you could times by 1 and then divide by 78. So long story short, the answer was 367. So I didn't actually mark yes or no to all of your questions along here, mostly because I wanted to force you to pay attention. So you don't even know which ones you got wrong yet until you actually follow along. Okay, second question. Which one's a halogen? Hopefully this one's just like you know it. Halogens are all in this column here, so the answer is D. That's kind of just you either know it or you don't kind of thing. Element B right here is listed on your table. If you find which one it is, this one I believe is niobium, which is NB. And NB is number 41 on the table, which means this right here should be 41. It has to have 41 protons. But I said, what if it's an ion? Well, if it was an atom, protons, electrons would be the same. But as an ion, there's going to be a different number here. So I need to know what niobium's most common charge is. And I believe the first one listed is +5. So if this guy's +5, he needs to lose 5 electrons. So if you lose 5 electrons, you're down to 36 now. So I was looking for 41 and 36. By the way, I'm going to go fairly fast because I only have an hour, but stop me if you do have questions, okay? This one here just wants me to test whether you know some more of these names. So is C a halogen? I'd say no. D is a halogen, so that one's wrong. Is A an alkaline earth metal? It's close. Alkali metals are actually the first group. This group right here are the alkaline earths, so that one's out. Is D a transition metal? And that's not true, because transition metals are somewhere in here. Noble gases, though, E over here, that one was a noble gas, so that one's D. Again, that's just kind of a knowledge question, not much work to it. And then last one on this series, now I'm asking about element A. So element A, I believe, is sodium. And sodium should have 11 protons because it's number 11. Here's a really key word then. I said this is an atom. As an atom, do you change number of electrons then? Okay, so that means your electrons is also 11. So it has 11 total electrons. And then new question, it's about energy levels. Well, this is energy level number 1. This is energy level number 2. This is energy level number 3. So there are 3 energy levels. And then last number, it's going to lose some electrons. Sodium is +1. So that means it wants to lose 1 electron. So it wants to lose 1 electron. Make sense? Okay. Wait, chlorine gas. Almost everyone that gets this one wrong picks A. But it's not A. The answer is actually B. The reason why is that chlorine is diatomic. It comes in groups of 2. So it's 3545 times 2. Because it comes in groups of 2. This is tricky. But it's actually really important to know that, though. Like, that's not a trick question. That'll come up quite a bit. Okay, here's one that requires some balancing. So, in order to balance this properly, let's see, do I have the answer here nearby? The way to balance this is that you need to put a 2 here, a 6 here, and a 6 here. So then in terms of answering it, this should have been a 2. This should have been a 6. What number should go in this spot right here? Yeah, if you put a 0 or you left it blank, I didn't mark it as right because it doesn't say as much, but there is a 1 implied that goes there. And for this guy, there is a 1 implied that goes there. So if you didn't put 2, 6, 1, 1, if you just put 2 and 6, I probably didn't count it as right. Or if you put zeros there, I think someone did that too. Okay, fluorine anions. Fluorine, if you look on your periodic table, is number 9. So that means normally it has 9 protons. But if it's an anion, it's gained an extra electron, because now an ion, so it should have 10 electrons. So that means it should have been one of these guys right here. And then it asks about silicon dioxide, and right off the bat, this should really mean something to you. If you ever have dis and tris and stuff like that, it's covalent, which means things share. So these are possible right answers, these are possible right answers, but the only row that has both of them being right was D. Okay, this is about isotopes. Sodium-23, right off the bat, if you look on the table, sodium is number 11, which means it has 11 protons, so it has to be either this one or this one. How do you tell about neutrons? Well, it adds up to whatever the mass is. So 11 plus 12 equals 23. So there must be 12 neutrons. All right, this is a pretty tough question. And they love phrasing questions like this if you take Chem 30 diploma exams. They love to give you a big list of things and then numeric response ask you which ones are right. And this question sucks because if you get 3 out of 4, you don't get the question right. Like you have to have all 4 numbers correct in order to earn 1 mark, which kind of stinks. So N2O4 is covalent. So that means it shares electrons. It does not exchange them. How do you figure out melting points? If they're covalent or ionic. Ionic things have high melting points, which means they're usually solids. Molecular things have low melting points, which means they're usually gases or liquids. So this guy should have a low melting point because it's a molecular covalent thing. So 4. So it should have gone 1 then 4. How do you figure out about strong or weak structures? Actually, it's the exact same thing. If you have a strong structure, you're solid. I can't put my hand through that. I just hit gas molecules. That's a pretty weak structure. Does that make sense? You can swim through water. So if you want to figure out how strong the structure is, solid things, which are ionic, will have a strong crystal structure. Weak things, which will be like liquid or gas, will be molecular. So this one should have been 5 then. And then lastly, anions and cations are negatives and positives. And that one's negatives only. So then it should be 8 because this is molecular. So the right answer was 1, 4, 5, 8. A lot of you had like 3 out of 4.
Yeah.
But if you don't have all 4, you actually won't earn a mark. Wait, here's another molar mass kind of question. So we have to do 3 things. First, we have to write down what ammonia is. So that's NH3. And hopefully that's coming pretty fast. Second thing is we got to do the molar masses for everybody. So N is 1401. Hydrogen is 101, but you're going to need 3 of them. So the molar mass is 1704 grams per mole. Still not the answer though, because we want to figure out grams. So I'm going to write out 2 ways of doing this. You could do 380 moles multiplied by 1704 grams per mole. Or you could do 380 moles multiplied by a mole for every 1704 grams. Which one's right? This one, it's the top one that's right. Because here the moles will cancel. So when you multiply these numbers by each other, you get 64.8.
Is that the answer?
64.8. Okay, this one's talking about a nuclear notation of trying to write out elements. The bottom number is like the atomic number, so like it tells you what it is. So 26 means this guy right here is iron. 27 means this guy is cobalt. 28 means this guy is nickel. And 28 again means this guy is also nickel. The top number tells you how heavy it is. So this is iron 56, cobalt with 60, nickel with 60, and nickel with 58. So now let's just talk about the first guy. AA should be described as having, let's see, iron is number 26, so it's got to be 26 protons. If 26 of these things are protons and it adds up to 56, then there must be 30 neutrons and 20 electrons. So this guy's B. Next question, we want to know which ones are isotopes of each other. Well, isotopes of each other have to be like the same substance but different masses. And this guy's nickel, and this guy here is also nickel. So the right answer for this one was 3 and 4, because they're both the nickel stuffs. I like to make up words. And I just did this earlier because I wrote them out in that notation. So I believe the right one would be nickel 58, because I think I wrote that out just a second ago on the previous slide. Questions? Like I said, stop me if I'm going fast. I'm going fast because I've only got an hour. So. Okay, this one's really tricky because I don't tell you what it makes. This is one of the first questions where you have to figure out what the products are going to be. What kind of reaction is going to occur when you have like a binary kind of thing here and then a single thing here? Single replacement, yeah. So the phosphate will go with the zinc and hydrogen will go by itself. So I'm just going to write this out right now. It would have made hydrogen gas and zinc phosphate. Okay. Hydrogen always comes in 2s, so that's hydrogen gas. Zinc phosphate right here, though, I have to write it properly. Zinc is a +2 charge, and phosphate is -3. Good. I haven't even answered the question yet. I'm just writing out what this should turn into. Okay, let's answer this question. The acid, which will be this guy right here, I mean, we need to know an acid name. This thing right here as a PO4 is called a phosphate. So the way the naming rules work is 8s turn into ic. So this is phosphoric acid. Why don't you put a hydro in front of it? Yeah, the hydros only happen if it's like H with F, or H with I, or H with just one item. Okay, for the next one, it's basically, again, a chart, and you have to pick out which one of these things is true. So the things that were true is it was a single replacement reaction. The gas that we made was hydrogen. And then now we need to use our chart to figure out the last thing. The ionic product, its solubility, we have to find this guy right here and figure out whether it's solid or aqueous based on our chart. So you guys know the chart I'm talking about? The one right here? So find phosphate, and then is zinc in the top column? It's not. So if it's in the bottom column, this guy should have been a solid. So then it should have been slightly soluble. So the right answer was 270. That makes sense? Okay, last one.
Get all those three?
You have to get all three, though. That's the thing, right? Like 2 out of 3 is. Last one, you need to then balance the equation. So I'm just going to go back to the original equation and try balancing it now. I believe you need to put a 2 here, a 3 here. That gives you 6 of those, and then a 3 here. And then that means this guy needs to just have 1. So the right answer for the next one should be 2, 3, 3, 1.
The one thing that sucks about these questions is if you get the first part wrong, it screws you up for the rest.
It is, yeah.
What's that lowest whole number from left to right thing?
Okay, so what you could have done then is it's possible that you could balance it with a 4, 6, 6, 2. That would still be considered balanced, but it's not lowest whole numbers.
How I thought you meant like in like order of the order.
No, this is basically just like what are the coefficients when you balance it. Okay. Okay, one last question on this. We need to then use mass and molar mass based on that ionic product, which I believe was zinc with a 3 and phosphate with a 2. So right off the bat, kind of like Shodi said, if you didn't get this thing correct, you're kind of screwed for all 4 questions, aren't you? Which is what I've been trying to say all unit, is that you have to be fluent in knowing these terms, because that's what we use in chemistry, right? So we're going to need zinc, which is 6541. You'll need 3 of those. You'll need phosphorus, which is 3097. You'll want 2 of those. And oxygen is 16, and you'll want 8 of those guys. So, I have this number somewhere. This guy's molar mass should be 386.17 grams per mole. Okay, last step. We've written the compound. We've found its molar mass. Now we're either multiplying or dividing. And in this case here, I'm not going to bother showing every single wrong answer one out. You're dividing, because that'll make the grams cancel. So the right answer was 178. You get that one?
So if you were like, if you just like put one there and make it all four.
Okay, we should talk about that sig digs. This thing right here has 3 sig digs. This one here has 5. So you need 3.
Yeah.
Yeah, sig dig rules from like physics still basically apply. It's the same idea. Okay. For this question right here, I give you a nice little story about this weird chemical compound called iron 3 oxalate. So first we got to make that chemical with iron being a 3+, and then oxalate, which I don't think I've actually ever shown you guys that much of. So if you found it on your periodic table, oxalate is an OOCCOO, and it is a 2 negative charge. So to make this work, you're going to need 2 of these guys and 3 of those. So that's first part of it. Then to answer my question, how many irons are there? Well, iron there are 2 of, yeah. Oxygen's a bit tougher. There are 1, 2, 3, 4 oxygens times 3, so that's 12. And then carbon there are 1, 2 times 3, which is 6. So it should have been 2, 12, and 6. All right, then I ask you another one of those ones where these things need to react with each other. I say we're going to react it with potassium chlorate. So this is potassium chlorate right here. What kind of reaction will this need to be?
Double.
Has to be double, because like here's an A and a B, and here's a C and a D. So yeah, double replacement for sure. I think we need to know that double replacement reaction for a follow-up question, so I'm just going to find it right now. It's going to become potassium with oxalate. And since potassium is a +1 and oxalate is -2, you're going to need 2 potassiums. And then you're going to want your iron to go with your chlorate. Iron, though, is 3+ and chlorate is 1-. So you're going to need 3 of those guys. Just maybe see whether I can make this a little bit neater.
When you're putting them together for double replacement, is it always just the 2 outsides and 2 insides?
Basically, like the outside guys will switch with each other, and the inside guys will switch with each other. So like this one will have to go with that far one over there. So like this outside one goes with this outside one, if that makes sense. And this inside one goes with that inside one. I think that's kind of what you were saying, right? I'm gonna try to like take all of this. Okay. There we go. Okay, so here's the equation. Maybe we can get rid of the C and D. We don't really need that. So now we have to go to our data table and figure out the solubility of these things here. So it's asking me about iron 3 chlorate first. So if you go to your data table, iron 3 chlorate, almost everybody is aqueous with chlorate. That one's probably not the hard one. Oxalate is the really challenging one. There is actually a spot in your data table for oxalate, if you have it nearby. It's the second last column, underneath IO3. And almost everybody is in the bottom column with oxalate, except for 4 exceptions. Iron oxalate is one of them, but that's not what we're talking about anymore. Cobalt iodate, NH4, and then group 1. Potassium is in group 1. So most people probably pick solid for this one, but this guy's actually aqueous, meaning that this one's very soluble, and so is this one, so the answer is B. Did anybody miss the fact that potassium is a group 1 ion? That's probably the most common mistake people make on that one. Okay, last thing we're going to need to do then is balance this equation. Balance this equation. That should work. So to balance this one, let's see. You're going to need 3 there, but that's a problem with those potassiums. So you're probably going to need 6 of these, 3 of these. That balances that thing. And then 2 of these. So you're going to want 1 iron 3 oxalate, 6 potassium chlorides, 2 iron chlorates, and 3 potassium oxalates. Okay, another one of those kind of questions where I'm going to give you a whole list of properties, and you've got to get all 4 of them right to earn the mark. So, tin. Let's walk through these one at a time. Is tin synthetic? No. No. How do you figure out if something's synthetic or not? Good. Has brackets on your table, so tin's not. It's also not an alkali metal because it's not in the first group. It's not a metalloid because it's not actually one of the ones exactly on the staircase, although it's close. But it is multivalent because multivalent means there's more than one charge. So tin, the only one that fits on here is 5 for tin. Cesium is in the first group, so that means that it's an alkali metal. Plutonium is one of those synthetic ones because it has brackets around its molar mass. And krypton is in the very last column. It's a noble gas, so it is inert. Inert. Unreactive, basically.
What does multivalent mean?
So multivalent means there's more than one possible charge for it. And like tin can be like a 2 or a 3 or something like that, or maybe 2 and 4. 2 and 4 it looks like. So if anything has more than one charge, it's multi, more than one valent, more than one valence electron kind of thing.
I got that right, but I just kind of like crossed out the other ones.
All right. Here's the answer for balancing this one here. Balancing is kind of a individual skill. Everyone does it probably slightly differently. So if you are struggling with balancing things, I can find you all sorts of practice questions if you want. But that's definitely a skill you need to kind of have down pat. So.
I got one of them wrong.
All right. This one right here, it says it's molecular. So right off the bat, we need to use dis and tris and tetra. So the right answer here is this is a carbon tetrafluoride because of the F4. Okay, this one's kind of like other questions we did, only a little bit less work. All we have to do is just find molar mass. So we need aluminum, sulfur, and oxygen. So this one is 2698. This one is 3207. And this one is 16. And this guy we need 2 of. This guy we need 3 of. And oxygen, there's 4 oxygens. But you need 3 of them? Yeah, so 12. So adding all that up gets you... Yeah, D, I guess. I have the answer sitting up here, by the way. D. 342.17. Okay, this one's kind of tricky. You need the acid name for this guy. The second thing in the acid formula helps you name it. If the second thing is just a single atom like bromine, chlorine, iodine, it's called the hydro something. But this is not just a single thing, so this cannot be a hydro something acid. Because that'd be like hydrobromic, hydrochloric, hydrofluoric. So this guy right here is called a silicate. Silicate. And 8s turn into ic. So this sounds kind of funny, but this is silicic acid. Absolutely. All right. This one's an interesting question because it gives you quite the story. Based on relative reactivity of chemicals, it tells you a story about this guy making a chemical that should not have existed based on our rules, and yet somehow it did. And the answer is C. And the reason why the answer is C is that this chemical has xenon in it. Xenon is supposed to be in the noble gas column, which means it should not ever go with anything ever, because it's supposed to have like full electrons. And yet xenon actually, like its most common charge is actually 0. But there are some very, very rare other charges that apparently xenon can have. 2, 4, and 6 actually. So that's how you can figure this one out here, is that xenon should not react, but apparently actually in some very rare cases we can make it react. Okay, here's another one where we need to do mass and molar mass. Now, if we're talking just about solid copper, we just need just straight up good old Cu. That's it. So its molar mass is 6355. So you're going to want to take 140 and go moles over grams. That way the grams will cancel. So if you do that, you end up with this number here. Here's another good way of thinking of that. If you want 1 mole of copper, you need about 63 grams. You don't have anywhere near 63 grams. So you should have nowhere near a mole. So like these guys are not possible. Right? Because if you need to have 63 grams to get a mole, and you don't even have even close to 63 grams, you're not even close to having a mole. Does that logic make sense? Okay. You had one like this on your last test. You got to know the different charges. Gallium is a +3. Manganese. Ooh, I need to look that one up. Manganese has 2 charges. It could be a +2 or it could be a +4, but it wants the most likely one, so it's +2. Neon has no charge, and hydrogen's most likely charge is +1. So then, writing this in properly, this needs to be number 1, this needs to be number 2, this needs to be number 7, and this needs to be number 3.
I got really confused on that, and I didn't know what one was.
For which one?
Hydrogen.
Oh, +1. Negative 1 is possible, but less likely because it's the second one. Alright, 10 left. Okay, we're looking to name this guy right here PbO. So Pb is lead, 4 is oxygen, so it's oxide, but lead has more than one charge. And so if oxygen is -2, that means lead has to be 2. So this should have been lead 2 oxide. Okay, now we need to do mass and molar mass again. So Pb is 207.2. Oxygen is 16. So when you put those together, you get 223.2 grams per mole. So this is dividing. Okay, this one was structured a little bit differently. When you get your answer is like 0.00337 and so and so. So in order to answer this one, it needed to be in scientific notation, which means pull the decimal place over 1, 2, 3 times and call it 3.37 times 10 to the -3. One of the nice things about questions like this is that this right here told you that it was supposed to be to the -3. So if you didn't get an answer that was to the -3, you know you're wrong. Does that make sense? Okay, balancing. Let's see, you're gonna want to do a 3 here. You're gonna need to, where's nitrogen? Put a 2 there, and you'll need 6 of those to get your oxygen. So this should have been 1632. If you didn't put the 1, by the way, right here, actually physically write it in, I probably didn't give you credit for it. Because even though it doesn't say as much, there should be a 1 there.
Oh, here's a 6.
Okay, this one caught a lot of people. Per sulfate would be like an SO5, whereas like a sulfite would be an SO3. Makes sense? Per sulfate is SO5. Regular sulfate would be SO4, and then sulfite would be SO3. So there are 2 more oxygen atoms from one to the other. Does that make sense? Per, regular ite, and then hypo. Alright, here we want to figure out how this reaction is going to work. It's going to be Na2S plus H2O. Like it tells you as much. It tells you here's sodium sulfide. It tells you here's water vapor. And we want to figure out what it turns into. Okay, this one is really tricky. It catches a lot of people. This is actually double replacement. And the reason why it's double replacement is that water is really an H and an OH. That's how water works. It's H combined with OH. So when you do your double replacement, your Na will go with the OH, making NaOH. And your H will go with the S, making H2S. So the right answer is sodium hydroxide. A lot of people, if they get this one wrong, they try doing this. They try to go Na2S plus H2O, and they make the H2 and the S go together. And they try to make the Na and the O go together, and they say it should be NaO. But that's actually not how water works. Water is an H and an OH. So the actual answer is sodium hydroxide, not just sodium oxide.
That's exactly right.
You did the sodium oxide? This one I threw a weird twist in. I said it had to be a polyatomic ion because aluminum actually makes a chemical correct with both B and D, but B is not polyatomic. So the answer is D. Okay, this is another one of those ones where you have to figure out the reaction. So it's going to be lead 4 chloride plus magnesium metal.
I thought it was lead.
D.
Oh, I actually
So you're going to take lead 4 chloride and add it to magnesium. What kind of reaction is this going to be? Good. So you'll have magnesium go with chloride, and you'll have lead solid. I believe this is aqueous, but I should look this up real quick. MgCl2. Yeah, this one's aqueous. So is it solid lead and magnesium 2 chloride? Well, we don't actually need the Roman numeral, so that's why A is out. It doesn't make chlorine gas, so that one's out. It again doesn't make chlorine gas, so that one's out. This one's right. It makes lead metal. That's lead metal, Pb. And it makes magnesium chloride. A is really close. But you don't need a Roman numeral for magnesium because it only has one charge. So this answer was D. Then you have to balance the equation. So let me rewrite it one more time. PbCl4. Oh, went the wrong way. Plus Mg, that was aqueous, that was solid. Made MgCl2, which was aqueous. And Pb solid. So now we need to balance this guy. And balancing is pretty straightforward. You just need 2's right here. So then the question here was, how many total atoms will everything have for just the products? So the products right here, you have 1 lead, you have 4 chlorines, and you have 2 magnesiums. Yeah, some people have the answer 284, but here's another thing. It had to be lowest whole number coefficients. So you should be able to reduce all of that then by dividing by 2. So not 284. Okay, if you use lead 2 chloride, it's still going to be single replacement. That doesn't change anything. But then when you have lead 2 plus with chlorine, where is lead 2 plus? The data booklet. Chlorine is soluble with lots of things, but lead 2 plus is in the exception category. So this thing should have been solid, meaning it should have been only slightly soluble. So the answer is D. Still single replacement, that doesn't change anything, but this guy's a solid now, not an aqueous. Okay, and last one. So you need to first write out the equation. It tells you what ethane is, it's C2H6. You have to add it to something to make CO2 and water. What is always the other thing in a combustion reaction? Yeah, oxygen. So last step, you need to balance properly. When you balance, usually do a 2 and a 3. And then this guy has to be 3.5. But you can't use 3.5, so you double it. So it becomes 2, 7, 4, and 6.